Before we go step by step through the process of creating a manual guide I program in detail, we will take a high-speed pass through the whole process with minimum explanations so you get a broad idea of the goal and a sense of how quick you can be creating programs in the future. First, we create the new program and give it a name. Next, we insert a start program fixed form sentence to set initial conditions and set the maximum spindle speed allowed in constant surface speed programming. Next, we define a material blank size. It's a 5-inch bar, 7 inches long, and the program's 0 point is 100 thousandths inside the end of the workpiece. Next, we rough face a part. First, we install a Start Tool fixed form sentence to select the tool and start the spindle. We have one specifically for the roughing tool. Now we're ready to rough face the workpiece. Machining cycles in Manual Guide I have two parts: the cutting conditions and the machine geometry. First, the cutting conditions. We are facing in the X- direction. We'll take one pass with a depth of cut of 70 thousandths. We'll leave 30 thousandths on the face for a finishing pass. The cutting feed rate is 12 thousandths of an inch per revolution of the spindle. All the values in the Detail tab are set to reasonable defaults, so we can move on to defining the geometry. When we define the geometry in Manual Guide I, we only define the material that we want to remove from the workpiece. All the motion for the approach clearance and escape amounts are automatically generated based on the values that are already specified in the cutting conditions. This allows us to use a coordinate specified on the workpiece drawing. So the start position is on the outside of the part at a diameter of 5 inches and Z is 0. This is the end of the finished machine part. It is standard practice to machine across the center line of the part by twice the tool nose radius. So we'll move to a diameter of minus 60 thousandths. Next, we machine in the positive Z to the outside of the blank. So that is plus 100 thousandths. Now we tell Manual Guide I on which side of the line is defined to remove the material, and then create the cycle. We will not reuse this profile, so we'll insert it in the main program. The final step in the facing operation is to insert the end tool fixed form sentence to stop the spindle, stop the coolant, and move to the tool change position. It is good practice to verify the program in the 3D solid model machining animation after defining each operation and troubleshoot any problems. Now we're ready to rough turn the workpiece profile. Again, we select the roughing tool and set the diameter to 5 inches. Now we select the turning outer roughing cycle. Again, we start with the cutting conditions. Depth of cut is 100 thousandths. We'll leave the 30 thousandths on diameter and faces for finishing pass. And again, our feed rate will be 12 thousandths of an inch per rev. All of the items on the Detail tab are good, except this time we are approaching X first and then Z. We insert that. Now we define the machining geometry. We started with a diameter of 1 inches and Z0. After setting the start position, we simply define the profile of the part as a series of lines. Our first part features a shoulder diameter. There's a line to the left. The end point of the shoulder is -2 inches in Z. Next we have a taper. The line moves left and up, and the end point of the taper is a diameter of 3 inches and -4 inches in Z. Note that Manual Guide I draws the profile as we define each line to give immediate feedback that we're moving in the right direction. Next we have a face. That's a line up to a diameter of 4.5 inches. Next we have a shoulder, a line to the left, to -5.5 inches in Z. The last feature is another face, a line up to the outside of the blank at a diameter of 5 inches. Now you can see the profile of the part looks about right on the screen. Now we need to close the blank. That is, to define which side of the profile to remove the material. Now we create the cycle. This exact profile will be used again for finish turning, so this time we'll create a subprogram that we can reuse later. We enter a name or number for the subprogram, and then the figure name is just a comment. It can be anything we want. We then insert the end tool fixed form sentence. And we can again run the simulator to verify the cycle is good. Now it's time for finishing operations. We start the finishing tool by inserting a fixed form sentence. This time we only have a diameter of 1 inch at the face because we rough machined the workpiece profile. We pick the finish facing cycle. The only value we have to provide in the cutting conditions is the feed rate. This time, we'll use 15 thousandths per rev. We start the geometry at the diameter of the roughed out profile. That is a diameter of 1 inch, and Z is again 0. Again, we'll machine across the center line to minus 60 thousandths. There is only the 30 thousandths of material on the face from the roughing cycle to remove. Again, we close the blank and create the cycle inside the current program. We'll go ahead and leave the Finish tool active and insert the Finish turning cycle. Again, the only cutting condition we need to enter is the feed rate of 15 thousandths per rev. Since we've already defined the finished profile in the roughing cycle and saved it as a subprogram, we cancel out of the geometry definition and select the appropriate subprogram. All that's left to be done is to end the tool and then the program by inserting fixed form sentences. We run the simulation one final time. There was a rough facing operation. There's a rough turning operation. There is a finished facing operation. And finally, the finish turning operation. That was a quick overview of the process, and we will now go through each step and explain everything in detail. Thank you for watching.